Okay, so today we're going to learn about radical equations part 2. And for radical equations part 2, here's a couple big ideas that I want to talk about. The first big idea is we're only going to work with radical equations again when they have an equation, so those things have to have an equal sign. So that's the first big kind of thing. Next big kind of thing, we're going to solve them like normal, like we've done in the past. But now there's going to be always a new step, and it's going to be called the check step. Because what you should have learned yesterday when you did these problems is sometimes when you plug your answer back in, you don't always get your answer to give you a solution. So we always have to check for our solutions. Okay? So we're going to try a couple different problems today. We're going to try to solve a couple different things and see how these kind of equations are a little bit different than the normal equations we're used to, like 3x plus 5 equals 10. So these are the big things. Make sure you have an equal sign, solve it, and then we're going to check our solutions. Let's try some example. Okay, so here's our first example. Again, we know this is a radical equation because it has this equal sign. And so we're going to solve, and we're going to solve it again like yesterday, where we try to get rid of the addition and multiplication first, and then deal with the square roots at the end. So the first thing that I can do is I can get rid of this 8. And when I get rid of this 8, I'll get 3x minus 5 is equal to 1. Then I'm going to square both sides. And you might go, well, why didn't I take care of this minus first? Well, if you see this minus sign underneath the radical, it's kind of like trapped. So we can't really deal with the 3x minus 5 until we get rid of the radical. And we get rid of the radical by squaring both sides. So then I'm going to be left with 3x minus 5, which is equal to 1. Now I can solve the rest of this. So we're going to add 5 to both sides. And we're going to get 3x is equal to 6. Then we'll divide by 3 and divide by 3, and we'll get x is equal to 2. We are not 100% sure, though, that this is the answer. We have to do what I'm going to call our last step, which is check. We need to check to make sure that 2 is the correct answer. So we're going to go back up to the original problem, and we're going to plug in 2. So the original problem was the square root of 3, but instead of putting x, we're going to put 2 plus, minus 5 plus 8, and that should equal 9. So then we just kind of go through and make sure everything works out. Well, 3 times 2 is 6. And 6 minus 5 is 1. And the square root of 1 is 1, and 1 plus 8 is 9, so 9 does equal 9. So it checks out. So this is actually a solution. So 2 is really a solution, and 2 is really my answer. So x equals 2 is an answer because we checked and made sure that it worked. Okay. Let's try a second problem. Okay, so for this second example, we're going to do the same kind of thing. We're going to try to get x by itself, so we're going to subtract 10 from both sides. We're going to get 5 radical 2x minus 1 is equal to negative 5. We're going to divide both sides by, 5. And we're going to get that radical 2x minus 1 is equal to 1. We're then going to square both sides. And I'm going to get 2x minus 1 is equal to 1. I'm then going to add 1 to both sides and get 2x is equal to 2. Then divide by 2 and divide by 2 and get x is equal to 1. Now again, we're not sure if that's the correct answer, so we now need to go into our next step, which our next step would be to check to make sure this is right. So we're going to check by plugging that 1 back into the original equation. So the original equation was 5 radical 2 times 1 minus 1 plus 10, and that should equal 5 for us. So let's see what we get. Well, I would get that this is 5, and that would be 2 minus 1, which would give me 1. And the square root of 1 is 5. Or, well, the square root of 1 is 1, and 1 times 5 is 5. And I would get that 5 plus 10 is 15, and 15, well, oh, that's not true. 15 doesn't equal 5. So this is not a solution, and I would say that my final answer is no solution. Okay. So again, in these two examples, we solved them just like we did yesterday, but at the end, you always have to check to make sure if your solution really is a solution or not. And sometimes it will be. So if you get that this side and this side are equivalent, then you know it's a solution, and x to the second is good. In this case, we looked and we go, oh, 15 is definitely not equal to 5, so it's not a solution. And that's a weird thing, because most times when we plug in things, we didn't actually make any mistakes in solving. The problem is, we didn't make any mistakes in solving. The problem is sometimes by squaring these numbers, you have some things that don't work out as nice. Let's try another example. Okay, so question number 1. This example is a little bit different because everything has radicals over top of them. So there's actually nothing that I can do right off the bat. So the first step that I would take, since I can't do anything right off the bat, is I would just square both sides. So that's the very first thing I would do. And when I square both sides, well, the square and the square root cancel. The square root and the square cancel. And you're just left with 3x minus 4 equals 2x plus 7. And now this is kind of nice because we can solve pretty easily. So when I solve this, I would subtract the 2x from both sides. And I'd get x minus 4 equals 7. I would add 4 to both sides. And I would get my final answer as x equals 11. Now, again, once we figure out what our answer is, we have to go back and we have to check. And we have to make sure that is true. So back in my first problem, we're going to throw that back in. So we're going to say 3 times 11 minus 4 is equal to the square root of 2 times 11 plus 7. Well, when we throw that in, that would be the square root of 33 minus 4 is equal to the square root of 22 plus 7. And that would give me the square root of 29 is equal to the square root of 29. Oh! This checks out. That is correct. So again, at the very end, plug everything in, make sure it works, and everything checks out. Let's try this problem over here. Again, it's going to follow the same kind of thing. We're going to need to square both sides. Oh, come on. There we go. And then what we're going to do is we are going to cancel out the square and the square root. Now this one works a little bit different. It's going to affect that and that. So the square root and the square will cancel, but then I do have to do 2 to the second. And 2 to the second would give me 4. And this side would be 4x minus 1. So just make sure if you have a number in front, you do have to distribute this to both terms. Then we would get 4x minus 1 is equal to, and notice I put parentheses because this 2 is affecting everything on the inside of here. So we do have to distribute this in this. So I get 12x plus 4 we would subtract 4x from both sides. I get -1 equals 8x plus 4. I'd minus 4 to this side, I'd minus 4 to this side. I get that 8x is equal to -5. I divide by 8, and I get that x is equal to -5 over 8. Okay. Now we'd have to take this answer and check it. So let's check it over to the side right here. When I check this, we again are going to plug this in at the very, very top. So I'd have 4 times -5 over 8 minus 1 is equal to 2 times radical 3 times -5 over 8 plus 1. And here, I know I'm going to run into some issues, and this is why. If you look at this side, you're going to get, well, we'll use our calculator to help us out. Let's figure out what 5 over 8 is. So we times that by 4. So that would give us -2.5 minus 1, so we'd get the square root of -3.5. And we're going to say that's equal to 2 times the square root of, well, again, I want to take -5/8 times that by 3, add 1, and we can see that, oh, that this time is a different number. I guess I kind of messed this up just a little bit, because we'd have 5 over 8 times 3, but that would be negative, and then we would add 1. So we'd have -0.875, and those things are definitely not the same. First off, you can't take the square root of a negative number, and second, we can see that the numbers on the inside don't work out. So right off the bat, we know these aren't the same, those aren't going to work out, and so we would say that this down here is not a solution. You're probably picking up on a pattern that negative numbers generally don't give us solutions very often, where positive numbers kind of do. But always make sure, you're throwing back in the numbers and checking. And that will be a really, really good way of making sure that you know how to do the problems. Try these.